All right, good morning, everyone, and welcome back to another exciting day of mathematics. Woo, woo. How's everybody doing? Good? Good. So warm-up number 36 is on your screen. For number one, it says complete the square and factor. And the polynomial given for number one is x squared plus 10x. Number two reads simplify square root of negative 49. Number three says factor by grouping. They give us the polynomial x squared plus 17x plus 16. And number four says find the inverse function f inverse of x for the given function f of x. And the given function reads f of x equals 3x plus 12. All right, so by now you should be able to do that one on your own. We did the previous warm-up together and see how you do. I'll give you some time. Copy and go. All right, so number one, they're asking us to do two things. The first one, complete the square, and then at the end, we factor. So how do we complete the square? I'm gonna add an extra term. So I put plus, then I take the coefficient of the middle term, and I do 10 divided by 2, and then square it. All right, let me rewrite this. So I got x squared plus 10x plus 25. Where did I get the 25? So what is 10 divided by 2? 5. What is 5 squared? 25. At this point, I factor. I'm done with completing the square. I just completed the square. So factor 25, 10, product, sum. What factors of 25 add up to 10? 5 times 5. I'm going to use a shortcut so I can write x plus 5 and x plus 5. Since they are identical, I can write it as x plus 5 squared. And notice the squared because we completed the square. Bam. Number two, simplify square root of negative 49. First, I need to rewrite it. Square root of negative 1 times square root of 49. What is square root of 49? 7. What is square root of negative 1? I. There you go. Number three, factor by grouping. 16, 17. Product of 16 that add up to 17. 1 times 16. All right. Now I can't write the shortcut because they're asking us to do it by what? By grouping. So that means I need to rewrite this. I bring down the x squared. Instead of 17x, we need to bring down these two. That means 1x plus 16x. Then at the end, I bring down the last term plus 16. And now I can group the first two terms, the last two terms. GCF here is x. We're left with x plus 1. GCF for these two is 16, and we're left with x plus 1. And now we can write our factors. It's the same here and here, x plus 1. What's left over? The x and the plus 16, so x plus 16. All right, last but not least, find the inverse function of f of x. So first thing, we change it to y form. So this is y equals 3x plus 12. Next step, we solve for x. So I need to leave x by itself. So I subtract 12, subtract 12. I end up with y minus 12 equals 3x. And last, to leave x by itself, I divide by 3, divide by 3. I'm going to rewrite this over here. So the 3 and the 3 here, leave the x by itself. So we're left with y minus 12 over 3 equals x. So just quick observation. We started over here by having the equation solved for y. Here it was, y equals 3x plus 12. And over here, we have the equation solved for x. Now, why is that so important? Because now at this point, now that we have it solved for x, we can interchange the variables. I'm going to interchange the x and the y. So now this will become x minus 12 over 3 equals y. And now this is the inverse because we just did the switch on the variables, but I just need to rewrite this, simplifying it. What is x divided by 3? It's 1/3 x. What is negative 12 divided by 3? Negative 4 equals, and instead of y, I'm going to write f, but I don't write f of x because that was the original. I'm going to write f with a little -1 here, which means f inverse of x. And this is my inverse. Inverse. How we do? Good? Yes, Mr. Q? All right, good. All right, all right. Okay, so that was warm-up number 36. Let's move on. Our agenda for today, we have warm-up number 36, which we just finished. Today, we're still transforming functions. And number 3, home plate, 3 transformations only. Only? Yeah. And once again, reminder, if you still are having problems, see what I did there? Problems with your home plate, make sure you you come during tutoring right after lunch, okay? Yes, Mr. Q. All right. Your asynchronous code for tonight is SGZ7F, SGZ7F. And once again, we're starting second semester. Make sure you don't fall behind with your synchronous sessions, please. Pretty please, with a cherry on top. All right. Your previous home play was this one on the screen, which you should have already done by yourself. You're not going to turn that in right now. You're going to submit that on your asynchronous assignment. You're going to see the slide come up. However, tonight's home play reads, do the indicated transformation for the to the following function. Graph f of x equals x squared using the domain -2, -1, 0, 1, 2. Then graph the transformations. Part A in green, g of x equals parentheses x minus 3 close parentheses squared minus 2. Part B reads in blue, g of x equals 4 times parentheses x plus 2 close parentheses squared plus 3. Part C in red, g of x equals 1/4 times open parentheses x minus 3 close parentheses squared plus 4. Okay, and once again, with your asynchronous code, you can get that on your own. I'm going to go ahead and move on. All right, our objective for today, I can transform a function using different parameters. I can transform a function using different parameters. And if you notice, we're still on the same objective. Why? Because we want to make sure that we complete all the parameters. And so far, we've introduced 3 different ones. That was your home play for last night. However, we started with our Freire model function. Do we know what functions are? Yes, write your own definition, one example, one unexample, and a hashtag. And some of you are like, Mr. Hill, how come you make us do one of these every time we meet? Because you need to know what we're working on, right? Yes, Mr. Q, this is our favorite. All right, good. And of course, you're just making your Freire model without looking at your notes by now, right? Because you know these by memory. Yeah, let's go. Anyways, you can finish that on your own. And quick recap, parameters. We've been working with those, and what are they? They're numbers that transform an original function into another function. That's what parameters are. We started our trip with transformations, and I said we start off with a 2-variable equation. From there, we change it to function notation. From there, we did a transformation for that linear function. And it was a +5 outside of the parentheses of f of x. I showed you how to do that with the table, but then we did an activity where I gave you the same function and we graphed the original function, which is known as a parent function. From there, we went to the transformation over here, which is f of x +5. The +5 is outside of the parentheses. And we saw that it moved all the points up 5 steps. And then f of x -2 and we saw that the -2 is outside of the parentheses, and that moves all the points down 2 steps. From there, I gave you guys this function on the screen, which has 4 points, and the reference points are -1, -2, 1, 2, 3, -2, and 5, 2. And then you connected those points, and it looks like an N. And then it says graph in green, g of x equals f of x plus 4. The plus 4 is outside of the parentheses, which means it moves all those points up 4 steps. And then the other one in red, g of x equals f of x minus 4. And the -4 is outside of the parentheses, which means that -4 moves all the points down 4 steps. From there, we moved on, and I gave you guys a general rule. And I said, from now on, whenever we do a transformation, we no longer label it f of x. Now we label it what? G of x, because it tells us that it's a transformed function. And on the right side, it should read f of x plus k, because we did something to the function f of x, which is the k, which is the parameter that moves it either up or down. From there, we moved on to a quadratic function, f of x equals x squared. We graphed that parent function, and then we asked to do 2 transformations, one in green, which reads f parentheses x minus 5. And since we saw that that number is inside of the parentheses with x, and that 5 moved all the original points 5 steps to the right. The red one, we saw that that number is f parentheses x plus 4. That number is inside of the parentheses with x, and that number moves all the points 4 steps to the left. From there, I gave you guys again that function that looks like the n with reference points -1, -2, 1, 2, 3, -2, and 5, 2. And it looks like an n. And I asked you guys to graph the green one, which is f parentheses x minus 2, close parentheses, which means that we're going to move all the points 2 steps to the right. Then from there, graph in red, f of parentheses x plus 6, close parentheses, and that number makes all the points move to the left 6 steps. From there, I gave you guys a general rule, which read g of x equals f parentheses x minus h, h being the parameter that moves the graph to the left or to the right. From there, I said, I'm going to give you now a rule that includes both parameters, parameter h and parameter k. And it reads g of x equals f parentheses x minus h, close parentheses, plus k. The k, once again, moves it what? Up and down, and the h moves it left and right. So far, so good, yes? From there, I gave you guys one last practice with this. We graphed a cubic function. Here it is. And then we did the following transformations in green, the +2 outside f of x, which moved it up 2 steps. The -3, it's outside of f of x, which moves it 3 steps down. The 6, which is inside with x minus, inside the parentheses, it moves all the points to the right 6 steps. And f of x inside of the parentheses +7 moves all the points 7 steps to the left. All right, and yesterday we started once again with a quadratic function, f of x equals x squared, using the domain -3 all the way to 3. We graphed the parent function, and then we graphed 2 transformations, one that says 3 times f of x and 1/3 times f of x. The green one, which is 3 times f of x, we saw that it was a whole number, and we concluded that a whole number, when we multiply f of x, it stretches vertically the function, whatever function may be. And the 1/3, meaning that it's a fraction, it compresses the function because we multiply it times that fraction. From there, I gave you guys the general rule, which was g of x equals a times f of x minus h, close parentheses, plus k. And once again, if you guys notice, the k is outside of the parentheses to the right of the parentheses, and that moves our graph up and down. The h moves our graph left or right, and the a either compresses or stretches vertically, okay? And then we did a couple of examples. We did examples Star Wars Q, where we graphed the quadratic function, parent function, and then they gave us a transformation, and then the other transformation, okay? So today, we're gonna do an exercise, guys, and this is what I call the anatomy of a function. And what does that mean, Mr. Q? Anatomy, which means I wanna make sure that you know each part of the function and what it looks like, whether it's transformed or not, okay? And in order for you to identify that, we're going to do a quick exercise today. That's why I asked you to get at least 3 coordinate planes ready from -15 to 15 on the X and the Y. Have those ready every time we meet. Like that, we're ready to go. And you're using your graphing notebook, yes? Okay, so let's get started. On the first, hold on. On the first coordinate plane, it reads example 1Q. Example 1Q. It reads graph, and then you're going to write f of x equals x. Using the domain -2, -1, 0, 1, 2, then graph the transformation g of x equals 2x minus 5. Copy that, and then we'll get started. Okay, I'll give you guys some time. Hurry up, please. All right, so let's start with this. But before we get started, way down here, guys, in blue, let's write our general rule, including all the parameters. Here we go. We have g of x, I'm going to write that in blue, equals to a times f parentheses x minus h close parentheses plus k. This is our general rule that has all 3 parameters. And this, put a big dot so that you know that we're multiplying right there. Now, the reason I want to have it down there handy, because I want us to start looking at it through the lens of that and looking at the transformation they're asking us to do. Hopefully that's going to help some of you look at it. And once again, the reason I'm doing this, guys, because I noticed the book presents certain things in a different way, and it's kind of shady. I wanna have you guys actually use my Q goggles. Let's go Q goggles. See what I did there? And like that, you are able to see what I see. You know what I'm saying? Because when you get to pre-cal, calculus, your teachers are gonna ask you to just look at a function and start seeing what's the function doing? Is it turning? Is it curving? Is it whatever? And you guys need to start looking at functions in that light. You know what I'm saying? Yes, Mr. Q. All right. So with that said, first things first, it says graph f of x equals x. Before I move on, look up to the screen. If you notice, f of x tells us that that's the original function. That's whenever they say f of x, that means that's the original function given. Whenever it says g of x, what does that mean, guys? That this is the transformation or the transformed function. Once again, f of x is the original, g of x is the transform. So I'm going to call the original the parent function, okay? However, look what it says, equal to x. Who notices that on the x there is no exponent? Yeah, there is no exponent. So what does that mean, Mr. Q? That when we graph it, it's not going to have any curves. If it doesn't have any curves, what does that mean? It implies that it's a straight line. It's a straight line. So with that said, to graph this over here on the left, I'm going to create a little table, x, f of x. And my domain, -2, -1, 0, 1, 2. Okay. So if I was to substitute this into my function, my f of x is going to be -2. You're like, how'd you get that, Mr. Q? Well, look up. Let me show you the process that we should be able to see by now. So I'm going to bring this down over here. F parentheses equals, that is that, right? But without the x. And equals, instead of the x, I'm going to just open a parentheses. So my first value that I would substitute in there is the -2. So if this is -2, over here should be x also -2. Can we simplify the right side anymore? No, that's why it's -2. What would be my next value? -1. And -1, -1, so that is -1. Next value is 0, 0, 1, 1, 2, 2. Let's graph this. -2, -2, -1, -1, 0, 0. Oh, I knew it. 1, 1, 2, 2. All right, get your ruler or your index card or whatever it is you use for graphing. There it is. And if you notice, it doesn't have any curves because it's a straight line. So now that we have our parent function, once again, we're going to focus on this parent function, and that now we're going to do the transformation given the g of x equals 2x minus 5. However, before we get started, write your utensils down, look up to the screen. Here goes the first go at it. See if you see what I see. Write your utensils down, look up to the screen. I'm going to go step by step on the transformed function that they gave me and matching it to my general rule. Okay, I'm going to use red so I can look at each part. So I see it starts with g of x. Do I have that on my general rule? Yes, there it is. Do I have an equal sign? Yes, Mr. Q, the equal sign's right there. Okay. What else do I have that looks familiar? An x. Here's the x right there. There's the x. However, who notices that it's missing parentheses around the x? You guys notice? Okay, so what that means, here, pay attention to this part. If there is no parentheses around x on this right side, that means there is no h parameter. Write that down, please. There is no h parameter. Once again, whenever there isn't a parentheses here around h on the right-hand side, on the side that's already being the function of g of x, that means there is no h parameter. Okay, so what does that mean? That this -5, circle it, corresponds to which parameter? What's after the x if there is no h? Oh, this one is our k. Okay, okay, see what I did there? Okay, anyways. And Josiel, I saw you, I saw you. So what does that make the number 2, guys? Which parameter? The number 2, it's in front of the x, and you're like, the f? No, the f is function. The parameter is a. So what are we noticing? That our transformation from now on, it's not going to have the little f for function anymore. Our general rule does, so that you can see that it's part of transforming f of x. But when they give you already a transformed function, such as g of x equals 2x minus 5, they're not going to have the little f in between the 2 and the x and so on and so forth. Okay? So let's continue. For the transformation, we always leave h and k to the end. Tell your neighbor what I just said, or whoever's there with you. We always leave what? H and k to the end. So that means we need to worry about a, because we want to know whether it's going to stretch or compress. So that means we're going to add an extra column here at our table. Do that in red. And we're going to multiply f of x times, what is a? A is 2. So we're going to do 2 f of x to see what happens to the original graph. All right, so what is f of x here? -2 times 2, that's -4. -1 times 2, that's -2. 0 times 2, 0. 1 times 2, 2. 2 times 2, 4. All right, let's graph that. So my first point is -2, -4, -2, -4. You don't have to make big points, make them, you know, normal size, because for the last transformation, we're going to make bigger points like that. We know that those are it, okay? So -2, -4. The next one, -1, -2, -1, -2. Next one, 0, 0, 0, 0. Next one, 1, 2, 1, 2. And the last one, 2, 4, 2, 4. All right, let's graph that. Okay. I'm still going to use black for the graph of that one. I'm going to leave the red points, but I'm going to use black for the line. So like that, we know that we're still not done, but we're one step closer. Okay. So what do you guys notice? That the graph, it's stretched vertically. Do you guys see that? If it was a rubber band, we stretched it vertically. Some of you are like, it just tilted, Mr. Q. Yeah, I get it, but I'm saying in regards to stretch or compress, it's stretched, yes? Okay, but are we done? Let's see, let's look at our function for the transformation. Look up, we're done with A, which is this one. What's missing? We have no H, so what is our last step? K. What does that mean? We move all these red points, how many steps? 5 down, 5 down. So let's start with this red point right here, 5 down, 1, 2, 3, 4, 5. Make it a bigger point. So like that, we know that that's our last one. This one, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. And the last one, 1, 2, 3, 4, 5. And this one I am going to do in red, our line. And this one I am going to label G of X. Why G of X? Because that's our final transformation. Okay. How we doing? Yeah, show me your fingers. How come you are with these so far? 5 4s, 5 4s. Okay. All right. So look up really quick. Who notices once again that we were missing the H? Yes. Okay. Well, Mr. Q, what would it look like if I had an H? Well, let me show you. Look up. Write your utensils down. I'm going to use green to show you. I'm going to rewrite this one, but now I'm going to include the parameter H. Here it goes. G of X equal sign A, then I have parentheses X minus 4, and then at the end minus 5. Look at it. Does it have the same A? Yes, Mr. Q. Does it have the same K? Yes, Mr. Q. So now what's the only thing that we included in this one? The H. What is H? 4. Is it becoming a little bit clearer? Yes? Yes, Mr. Q. All right, good. All right. So I showed you one, we graphed one with the parent function. They gave us a transformation without an H. I just showed you one with H. I'm gonna write another one in red, look up, and I want you to identify all the parts or all the parameters, my bad, and identify if there's any parameters missing. Here we go. G of X equals parentheses X plus 3. Look at it. Identify your parameter or parameters and see which one is missing, if there's any missing. All right. Are there any missing? Let's see. Help us out. Jaziel. Which ones are missing?
A and K are missing.
Yes, that is correct. There is no A. Man, Jaziel, let's go. And there is no K. So what is the only thing that we have to transform the original one? We have H. Since this is a plus 3, remember this is supposed to be negative according to the general rule. That means this would move our graph 3 steps to the left. Is it becoming a little bit clear? Yes? All right. Well, guess what, guys? Right now, we did one transformation using this parent function, which was a linear function. Well, I can tell you that we can use the same parameters to do transformations now for a different kind of function. Let's move on to the next one. So let's go to the new graph, new coordinate plane. Here we go. On your new coordinate plane, I want you to write example 2 super Q. You're using a clean one, yes? And again, you're gonna write graph, and you're gonna write f of x, which means it's an original function, equals to x squared. X squared. Using the domain -2, -1, 0, 1, 2, then graph the transformation g of x equals to x squared minus 5. And hopefully you're like, wait a minute, that looks very familiar, Mr. Q. Yes, of course it does. I just want to make sure I'm hammering this out so that you guys can see all the components. I'll give you some time to copy that. Hurry up, hurry up. All right, so look up to the screen really quick. I'm gonna write my general rule once again down here in blue. G of x equals a times f parentheses x minus h close parentheses plus k. However, look what I'm gonna do to the general rule now. Look up to the screen. Look up. Look up. Sorry, like, man, Miss Q. Who notices now that we are dealing now with an exponent of what? 2. So on my general rule, look what I'm gonna do. Here's my x, here's my parentheses, and I'm gonna place a 2 right there. Do the same, please. Everything else stays the same. The only thing that changes is the exponent. On the previous one, we didn't have an exponent because there was an invisible 1, because it was a linear function. This is a quadratic function. Okay? So now that we have it like that, that's going to help us guide ourselves as we look at the transformation once we get there. But for right now, let's graph the original parent function. So over here on the side, I'm going to write x, f of x, -2. And what is the function that they ask us to do? Square it. What is x squared? That means -2 times -2. -2 times -2 is 4. -1 squared is -1 times -1, which is 1. 0 squared is 0. 1 times 1 is 1. And 2 times 2 is 4. Let's graph this. -2, 4. -1, 1. 0, 0. Oh my goodness. 1, 1. 2, 4. All right, graph your parabola. All right, so if you notice, now that we have an exponent other than 1, now we know that this is a curve. Whenever it doesn't have an exponent, it's a straight line. It's a linear function, okay? So now that we have that, let's go to the transformation. I'm gonna switch to red. Let's match each part, okay? Here we go. G of x, do we have that here? Yes, G of x. Do we have an equal sign? Yes, an equal sign. Do we have an x? Yes, an x. Do we have an exponent? Yes, this is a square. Does it have a square? Yes. Okay. So, what else do we notice? That this x doesn't have what, guys? It doesn't have a parentheses. If it doesn't have a parentheses, what do we write? What, Alberto? What do we write?
No idea.
Very good. No H. That is correct. No H. If the X does not have a parentheses, there is no H. Okay. Circle the 5. That means that the 5 is our K. And the 2 is our A. Okay. Does that look a little bit better? Yes. Now, if you notice, everything's following the same general rule, but now that we have an exponent, it helps us kind of like compress the X and see that there is no parentheses, like on the general rule, there is no parentheses. So that's why we can identify that there's no H. So for our transformation, since we always leave H and K till the end, what do we need to worry about right now? The A. So that means we're going to add an extra column here for our table. And multiply the A times f of x. So that is 2 f of x. Okay, Angie, help me fill this out. What do I write here?
Eight. 2. 0.
Yes.
2 and 8.
Thank you. All right, let's graph that. We got -2, 8, -2, 8, -1, 2, -1, 2, 0, 0, 0, 0, 1, 2, 1, 2. And then we got 2, 8, 2, 8. So what did it do to the original function? It stretched it. You guys see that? It stretched it. Yeah? You're like, yeah, okay. You know what? I'm going to change that one to black. Just so, I'm going to leave the points in red, but in black because we're still not done transforming it. So there it is. There it is. Okay. All right. The point's still in red. That shows us that it stretched the original vertically. Okay, there it is. Are we done? Let's see. Let's look at a transformation. We're done with A. What's missing? K. What does that mean? We need to move all those 5 points, the red points, what? 5 steps down. So let's start on this one. We go 1, 2, 3, 4, 5. I'm going to make it big. So like that, I know that's my final point for that one. This one, 1, 2, 3, 4, 5. 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 And we graph this one completely in red. There it is. And this one we're going to label g of x. Why? Because that's our transformed function completely. Okay, and once again, what did we say that it didn't have? It didn't have an h. That's why if you notice, this graph did not move either to the left or to the right. It just moved down, okay? However, Mr. Q, what does it look if it had an H? Look up, please. I'm going to use green. I'm going to rewrite this. Look up this one, the transformation one, but now with an H. Here we go. G of x equals 2. Since it has an H now, I'm going to open up parentheses, x minus 4 squared, and then minus 5. Can you guys see it now? Yes, look at the general rule and look at this one. Let's match it. What is 2? That is A. What is 4? H. And what is -5? -5 is our K. Does that make sense? You're like, yes, Mr. Q, I see it. Let's go. Let's go. All right. So I think you got it, but let me just double check. I'm going to give you a red one, and I want you to label the parts, the parameters, and keep in mind if there are any missing, because I'm going to ask you if there are any missing. Write this down. G of x equals parentheses x plus 3 close parentheses squared. All right, label your parameters and think of it, are there any missing parameters? Let's see. How about Hayden? Let's say, shed some light for us. Get it? I see your background. That's Are there any parameters missing, Hayden?
A and K are missing.
That is correct. There is no A here, and there is no K there. So the only one that we have is H. If it's a positive 3, what is its inverse? Negative 3, which means we would move this black parabola 3 steps to the left. Yeah, let's go. We got this, yeah? Show me your fingers. How come you are with these? Got some 4s, 5s, 4, 5s. Okay, all right. So if you notice, the setup looks pretty much the same. The only thing now we applied it to a quadratic. Well, guess what? It's going to do another one now. We're going to apply it to a different function. So let's start a new one. Here we go. On your new coordinate plane, I want you to write example 3 in mega Q. And then we're going to write graph f of x equals x cubed. Using the domain -2, -1, 0, 1, 2. Then graph the transformation g of x equals 2x cubed minus 5. You're like, oh, I see what you're doing, Mr. Q. Yes, by now you should be able to see this, right? I'll give you some time to set up. Ready, go. All right, let's see what we got. So before we get started, once again, let's write our general rule down here. And the general rule reads g of x equals a times f of parentheses x minus h close parentheses plus k. However, look up to the screen. What function do we have now? It's a what? A cubic, which means here outside the parentheses, what are we going to write? The cube. Hands if you did that by yourself. Some of you are like, I forgot. We'll stay on it. My goodness. All right, here we go. Let's graph our original function over here, x, f of x, -2. What are we doing now? We're cubing it. That means -2 times -2 is +4 times -2, that's -8. -8. -1 cubed. -1 times -1, +1 times -1, that's -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. All right, let's graph that. -2, -8. It's down here. -1, -1. 0, 0. 1, 1. 2, 8. Okay, so that's our parent function. So before I move on, let's see if you can identify the parameters that we have on that transformation. What do they give us? What don't they give us? Let's see, Anthony, what do they give us on our original transformation here?
A and K.
So which one's A?
2.
And K?
5. -5.
-5, yes. So we have -5 as K and 2 as A. So that means if X doesn't have a parentheses, that means we have no H. So since we're going to leave the K till the end, we need to do H. So we add a column here for our table. Two times f of x. Okay. So what do I write here? Esmeralda.
-16.
Uh-huh.
-2.
Uh-huh.
0. 2. 16.
Thank you. Let's graph this. -2, -16, -2, -16 way down here. -1, -2. 0, 0, 1, 2. And 2, 16. All right. I'm going to do my curve again in black, just the points in red so that I show that I'm doing either the stretch or compress. And by the looks of it, it stretched it. Is that correct? Yeah, it stretched it vertically. What's our last step? Addie.
We have to use K and bring them down.
Bring all points down. Since this bottom one over here, I can't, it's off my screen. I'm going to go to the next one up, which is this one, 5 steps down. 1, 2, 3, 4, 5. I'm going to make that point pretty big. So like that, I know that's my final one. This one, 5 down. This one, 5 down. And this one, 5 down. 1, 2, 3, 4, 5. And I'm going to graph that one in red. And this one I am going to label G of X. How we doing? Yeah? I hope this exercise helped, guys, so that you could see all the components of the transformation and its parameters. So with green, I want you to write me this same one, look up, this same transformation, but I want you to include an H now. Do that yourself. I just started you off here. There it is. See what you can write by yourself. Write me a transformation using those parameters, but now include an H. All right. Let me show you mine. I have A is 2. Now, since I'm including an H, I'm going to open up parentheses, and I'm going to write X minus 23, Michael Jordan, cubed minus 5. K stayed the same, is that correct? Yes. A stayed the same, yes. So what is the only thing that I added? I added an H, which is 23, which would move this last one 23 steps to the right. This is A, and this is K. Okay? Okay. All right, and last but not least in red, look at this one. G of X equals parentheses X plus 1 cubed plus 7. Which parameter is missing? And label the other parameters and in your picture, in your noodle picture where it's gonna move. All right, let's close this up. Jaziel, which one's missing?
A.
A is missing. That is correct. There's nothing there. So K is going to take us 7 steps which way, everyone? Up. And the positive 1 inside with X, which is H, is going to take us what? 1 step to the left. Yeah, we got this, yeah? Let's go. Man, this is tweezy. All right. We're going to go ahead and stop right there, guys. And once again, our home play, let me go back to the beginning. First of all, our synchronous code for tonight is SGZ7F, SGZ7F, and the home play is on the screen. So make sure you get to that. You have your synchronous code. If you need to come in for tutoring, I'm here after lunch. So have a good one, guys. Nice seeing you all. Peace. Bye.
Bye, Mr. Q.